In this video, we're going to work on the hard problems of the SAT, focusing on quadratics. Now the problems that you're going to see here are going to be focused on what I've experienced students suffer with the most over the years, and we're going to have the quadratic formula up here on the right. So for this question, we're going to look at positive solution. And the reason why we talk about this positive solution is because of the quadratic formula. There's a plus or minus sign. So that's going to give us one answer that has a plus and one that has a minus. When we're looking at the positive solution, it's meaning that we're only going to be looking at one of the values of x, and we're going to be looking specifically at that positive one. So to solve for this equation, we have to have x all on one side. So to do that, we're going to multiply by x on both left and right side of this equation. What that will do is that's going to cancel out x out on that side. So we'll be left with 72 is equal to x squared minus 3x. We'll move 72 over to the other side by subtracting it on both sides. That will cancel out. Then we're going to have 0 is equal to x squared minus 3x minus 72. Now with that information, we can see that we are going to be solving for a quadratic. We have our value for a, b, and c, with a being 1, which we can put up in the front of x squared. So what we'll get with this is x is equal to negative times a negative 3 plus, and only plus this time because we're just looking at the one positive solution, the square root of negative 3 squared minus 4 times 1 times negative 72 all over 2 times 1. Now if we simplify this, we're going to get negative and a negative, so that's going to be positive 3 plus the square root of 9 minus, and another minus will make that positive. 4 times 72 is going to get us 288 all over 2. We can simplify this more to 3 plus the square root of 297 all over 2, and that would be our answer. Now for this question, it's always good to read it first. So it says that one solution to the equation can be written in the form of a minus the square root of b. Now don't take that into consideration that means the a value and b value for our quadratic. What this is meaning is after we solve this quadratic, we're going to get a form that will look similar to this, where we have a value of a and we have a value of b. It's then going to ask us, what is the value of a plus b? So once we find those two values, we're just going to add them together. Now we have a quadratic here, but it's not in standard form. So for us to put this in standard form, we're going to move that 4 to the other side and the 6x to the other side. If we do that, we're going to get x squared minus 6x plus 4 is equal to 0. We can put a 1 out in front, and that's going to give us a value for a, b, and c, for which we can plug into the quadratic formula. With that, we're going to get negative times a negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 4 all over 2 times 1. We can simplify this to 6 plus or minus 36 minus 16 all over 2. And that will simplify to 6 plus or minus the square root of 20 all over 2. Now this is not in the form of a minus the square root of b, so we need to simplify this out even more. So we can simplify the 2 and put that in fractions for both of our items. So we're going to get 6 over 2 plus or minus the square root of 20 over 2. That's going to simplify to 3 plus or minus the square root of 20 over 2. Now we can't have this 2 in the bottom because it still doesn't follow those formats, so we have to simplify this even more. Well, we know that the square root of 20 can be simplified to the square root of 4 times the square root of 5, because 4 times 5 will be 20. If they're both inside of a square root sign, we can actually separate those out as long as they both have one. Well, we know that this simplifies to 2 times the square root of 5. So with that information, this right here would be 2 square root of 5 over 2. That will simplify. So now we're going to get an answer of 3 plus or minus the square root of 5. Well, that's going to be our value of a and b, just like we were told we would have. So once you know that you have that format, then you know you're going to have the correct answer. So what's the value of a plus b? Well, that would be 3 plus 5, which would give us a value of 8. And that would be our answer. So for the next question, it's asking the quadratic equation is x squared plus qx plus 30 is equal to 0. Where q is a positive constant, so it's a positive number. And the equation has integer solutions, so it means it's going to be a whole number. It's not going to be a fraction, it's not going to be with a radical, and that can help us with solving the problem. And then it's going to ask which could be the following value of q. So could we have 11 here, or could we have 17 or 14 for this value of q? Now there are going to be problems where you don't have to do the quadratic, and we can actually solve in a couple different ways. So for this one, we're going to be factoring, or we could be using something like the diamond method. So if we have something like x squared, we have plus qx, we don't know what q is, plus 30. We know that the last value is going to tell us what value we need to multiply. And the value of q would tell us what would add two values together to get that. So if we put 30 here, we want to figure out what two numbers multiply to 30, but then add to q. Well, we have three different values we can put in for q. So we could put in, say, 30, and we can put in this first value of 11. Well, what two numbers multiply to 30, but add to 11? And that would be 6 and 5. Meaning that if we had two solutions, it'd be x plus 6 times x plus 5 is equal to 0. And that could actually just be factoring out that equation that we have. So we know that 11 would be one value for q that would work. Now what about another value? Let's try 14. So what two numbers can we put into our diamond that would multiply to 30 but add to 14? And there are none, right? We could have the numbers that multiply to 30 would be 30 and 1. We can see 3 and 10. We can do 6 and 5. And we can go 15 and 2. None of those numbers add up to 14. We'll get 31, 13, 11, and 17. So that wouldn't be the case. But again, we have that 30 and 17 for that last one. And again, it would be 15 and 2 would be those values. So we know that 1 and 3 would be the only integer solutions that would work. 14 does not. Now the next question is asking, what is the sum of solutions to the equation? And we have our quadratic here, however, it's not in standard form. Now we could put this into the quadratic formula. And since it's asking for the sum, it's asking for the addition of the two solutions. So the one with the plus and then one with the minus, and then add those two values together. However, there is a shortcut that we can do to solve this. And the shortcut to adding the sum together is given by the equation of negative b over a. So if we figure out what our values of b and a are, we could just put that in instead of doing the full quadratic equation. So to do that, we're going to need to move that 21 over here and that 14 over to one side. They all have to be on one side of the equation for us to solve it. So what we're going to end up getting is 5x squared, which will be our a, minus 7x plus 2 is equal to 0. Once we have those two values, we can plug it into our equation. So we'll get negative times a negative 7 over 5, and that's going to give us an answer of 7 over 5. Now, if you're really unsure that this actually works, feel free to put the quadratic in, find those two solutions, and add them together, and you will find out that you will get that same answer. Now for this next question, it says we have the equation right here. And k, which is shown up here and here, is a positive constant. And we want to find the product of the solutions. And the product of the solutions is equal to this value of w times 2k minus 5. And so now we need to figure out what is the value of w. Now we took a look at the sum, and we remember that the sum of the equations is equal to negative b over a. Well, now we're looking at the product. So if we take our two solutions from the quadratic formula, the one with the plus and the minus, and we multiplied those two values together, we would get the product. Well, the product also has a shortcut. And the product is actually going to be c over a. Now with that information, that can help us actually figure out and solve this. Because we know that from our equation that we have, it is in standard form. We have an a, we have b, which is actually going to be two numbers, plus this minus sign. And we have c, which is going to be this inside of parentheses as well. So with that information, we can plug this in. We'd get 2k minus 5, which is equal to c, and our a is going to be equal to 6. And so that is our product right here. But we also know that the product of the solution is equal, hence that word equal, so that's going to be equal to w times 2k minus 5. Well, we have what that's equal to right here, so what we can do is just end up solving it together. So we know that we have this 2k minus 5, and we have 2k minus 5 right here. We can rewrite this one on the left as 1 over 6 times 2k minus 5 is equal to w times 2k minus 5. Since we have 2k minus 5 in parentheses on both sides, we can cancel that out. So we're going to get the w is equal to 1 over 6. So the next thing we're going to look at is called the discriminant. Now the discriminant is this part of the quadratic formula that's inside of the square root sign. And what the discriminant actually tells us is that if we have a number, which we'll call the discriminant, and it is greater than 0, it's just a number, that means that we're going to have two solutions. Now if the discriminant is equal to 0, it means we have one solution. And if we get that the discriminant is a negative number, well, we can't take the square root of a negative number. So what that's going to mean is that we don't have real solutions, or we're going to have no real numbers, no real solutions. So now with that information is that can help us actually solve for w. Because it's telling us that the equation has exactly one solution, meaning that if we want to know what that one solution is, or that one real solution, we don't have to do the full quadratic, we can just do the discriminant to help us solve it. So what we need to do first is move this into standard form. Now w is a constant, so what that's going to tell us is that we're actually going to see that value as our c value. So we have our a, we have our b, and we have our c. Since we know that it's telling us the answer is going to have one solution, that means that we can set the discriminant to 0. So again, our discriminant is equal to b squared minus 4ac. And we have those values, so we're going to have negative 6 squared minus 4 times negative 12 times w. And again, our discriminant is going to be equal to 0, so we can put 0 on the other side. We'll get 36 minus a negative, so that'll be a positive 48w is equal to 0. We'll move 36 to the other side. We're going to get w is equal to negative 36 over 42. And that would simplify to the value of negative 3 over 4.